Hi, Assalamualaikum and good day. Today you are going to learn on how to find the eigenvalues, eigenvectors and normal eigenvectors for a given square matrix. We can represent a large set of information in a matrix. Eigenvalues and eigenvectors are used to capture key information that is stored in a large matrix. They are used to compress the data and reduce the dimension space. Eigenvalues and eigenvectors can help us to understand the data better as they can be used to transform and represent data into manageable sets. This is the objective of today's lesson. Hopefully, by the end of this session, you should be able to find the eigenvalues, eigenvectors, and normal eigenvectors for any square matrix. Let's start with the following. If we multiply n by n matrix denoted by A with n by 1 vector denoted by x, we will obtain a new n by 1 vector back, which can be represented as kx. K here refers to a constant which can be either real or complex. Any value of k for which the equation has a solution is known as eigenvalue of matrix A. The column vector x, which corresponds to this value k, is called as eigenvector of A. The equation ax equal to kx can be written as ax minus kx equal to 0. Factorizing the x, it becomes a minus ki multiplied with x equal to 0, in which I here refers to the identity matrix. To find the eigenvalues, first assume that the determinant of a minus ki equal to 0. Then, solve the determinant to find the values of k, which are known as the eigenvalues of matrix A. If the square matrix is of order n, we should obtain n eigenvalues. Once we have the eigenvalues, we can find the eigenvector for each eigenvalues. To do this, first substitute the k value into the following system of equation, that is a minus ki multiplied with x equal to 0. Then, solve the system using Gauss elimination method. And finally, represent the x values in matrix form. This should be the answer for the eigenvector corresponding to the eigenvalues. Normal eigenvector refers to the unit vector of the eigenvector x, which can be determined using the formula x over its magnitude. Magnitude of x, which is denoted by modulus x, refers to the length of the vector, and it is obtained from the following formula, that is the square root of the sum of the elements with the square. Refer to example 34. You need to find the eigenvalues and the normal eigenvector corresponding to the largest eigenvalue of the following square matrix of order 2. As the square matrix is of order 2, you should obtain two eigenvalues. To find the eigenvalues, assume that the determinant of A minus Ki equal to 0. A minus Ki refers to matrix A with all the elements in the main diagonal is minus by K. To solve determinant of order 2, cross-multiply the elements and subtract. You will obtain a quadratic equation which is known as the characteristic equation. Solving this equation, you will get two eigenvalues which are k equal to 5 and k equal to negative 2. Here, the largest eigenvalue is k equal to 5. Next, to find the corresponding eigenvector, substitute k equal to 5 into the equation of a minus ki multiplied with x equal to 0. Then, solve the equation using Gauss elimination method. To do this, write the augmented matrix by combining matrix A and matrix B. Then, reduce this matrix to row echelon form. Go to the first row and find the leading. As the first non-zero value is -3, multiply the first row with -1/3. Then, obtain 0 below the leading by performing row operation R2 minus 4R1. As the matrix is now in row echelon form, proceed with the second stage of back substitution. Based on the augmented matrix in row echelon form, there is only one equation that you can obtain, which is x1 minus x2 equal to 0. As the number of equations is 1 and the number of unknowns is 2, you need to assume that there is another equation by letting x1 equal to t. Solving the equation, you will obtain x2 equal to t. Combine all the unknowns in matrix form, you should obtain the following answer for the eigenvector. In order to find the normal eigenvector, find the magnitude of x first, which is equal to the square root of t squared plus t squared. Simplify, you will get square root 2 multiplied with t. Substitute this into the formula of normal eigenvector, that is x over its magnitude, and simplify, you should obtain the following answer for the normal eigenvector. Take note that the answer for the normal eigenvector is in value only, no more t inside. Proceed with example 35. You need to find the characteristic equation of the given matrix A, the eigenvalues, and also the normal eigenvector corresponding to the smallest eigenvalue. As the square matrix is of order 3, you should obtain 3 eigenvalues. To find the eigenvalues, assume that the determinant of A minus Ki is equal to 0. To solve the determinant of order 3, you may use the cofactor expansion or minor expansion along the first row, which is A11 minus 11 minus A12 minus 12 plus A13 minus 13. To calculate the minor, cross-multiply the element and subtract. To solve the k value, it is easier if you can factorize the common factor instead of expand the whole equation. By moving the factor 2 minus k to the front and simplify, you will obtain k squared minus 4k plus 3 as the remaining expression. Factorize the equation. You will obtain 2 minus k, k minus 1, k minus 3 equal to 0. Therefore, k equal to 2, k equal to 1, and k equal to 3 are the answers for the eigenvalues, where the smallest eigenvalue here is k equal to 1. Next, to find the corresponding eigenvector, substitute k equal to 1 into the equation of A minus ki multiply with x equal to 0. Then, reduce the augmented matrix to row echelon form. Go to the first row and find the leading. As the first non-zero value is 1, proceed to obtain 0 below the leading by performing row operation R2 plus R1 and R3 minus R1. As the matrix is now in row echelon form, proceed with the second stage of back substitution. Based on the augmented matrix in row echelon form, there are two equations that you can obtain, which are x1 plus x3 equal to 0 and x2 plus 4x3 equal to 0. As the number of equations is 2 and the number of unknowns is 3, you need to assume that there is another equation by letting x3 equal to t. Solving the simultaneous equation, you will obtain x2 is negative 4t and x1 is negative t. Combine all the unknowns in the matrix form, you should obtain the following answer for the eigenvector. In order to find the normal eigenvector, find the magnitude of x first, which is equal to the square root of negative t squared plus negative 4t squared plus t squared, which can be simplified to square root 18 multiplied with t. Substitute this into the formula of normal eigenvector, which is x over its magnitude, and simplify, you will obtain the following answer for the normal eigenvector. In order to check your understanding on this lesson, please do the following exercise. In the next lesson, you are going to learn chapter 2 that is on vector algebra.